everybody! Today the topic that I will focus on is the application of triple integral in cylindrical coordinate. In this case, we want to know the volume of the cup and how could we solve it. The result is by using triple integral. Since we know that the cup has a cylindrical shape with 10 centimeters height, and when we draw a cylinder in 3 dimensions, we can see that the plane Z is at least 0, but no more than 20 centimeters. Then we project to the XY plane, and we can see that R is at least 0, but no more than 6 centimeters, and zeta is no less than 0, and at most 2 pi. After we know all the value of Z, R, and zeta, now we can use this to find the volume of a cylinder.
Hi guys, so today I'm going to find the volume of the cylinders by using a cylindrical coordinate. Alright, I will write down the formula. Here we go. The triple integrals of the V equal to the triple integrals of R, the C, dr, and d data. So we know about the height of a cylinder. So the boundary between from the C between 0 to 20, and the R between R is the radius of the cylinder. So it's 0 to 6, and the data is we determine a XY trait. So the angle from 0 to 2 pi, and then at the next step we find the triple integral. We determine the inner integral first. So these belong to DC, and then we determine the integral of DC first. So we write again from 0 to 2 pi, from 0 to 6, and R, C bounded from 0 to 20, dr, and d data. So at the next step, we substitute the 20 to C and 0 to C. So in the final result of the integral of DC is equal to 0 to 2 pi and 0 to 6, and this becomes a 20 R dr d data. So in the step that we have done before, from the DC, then we determine the dr. So there is no space here. Then I will move on to the other side of the page. Here we write the equation 0 to 2 pi, then from 0 to 6, to 6, and 20 dr d data. So when you integrate the dr, it's become a 0 to 2 pi and 20 is r squared over 2, and bounded from 0 to 6 the data. So you can cut from 2 and 20 is become 10, and the final results of the integrals of dr is become a 0 to 2 pi and 10 times r squared, and bounded from 0 to 6, and the data. So I will write down the easier way, to go off to 2 pi, and substitute 6 to the r squared and 0 to the r squared, and then it's become 10 times 6 squared d data. So I move on to the next page. Alright, then we got 0 to 2 pi 10 times 6 square and the data. So I will calculate these terms from 0 to 2 pi and 360 the data. So it just the one integral the data is become a 360 data but from 0 to 2 pi. And then we substitute 2 pi to the data and 0 to the data is become a 360 times 2 pi. The volume is about 2,261 centimeter cubed. This is the final answer.